The Thumb 2 technology and instruction set architecture. The Thumb 2 technology is an advanced version of Thumb instruction set. First of all, we will look at Thumb instruction set. Traditional ARM processor supported two set of instructions. One is ARM instruction set, another one is Thumb instruction set. ARM instruction sets are 32-bit, Thumb instruction set is 16-bit. If you compare Thumb instruction set with ARM instruction set, Thumb instructions requires less memory compared to ARM instruction set. So in traditional ARM processors, one requirement is to reduce the memory requirement, which is one feature the portable devices is expecting. Due to that reason, few instructions like move, add, or some few common instructions are also possible to implement using Thumb instruction set, and equivalent ARM instruction set is also available. But ARM instruction set consumes 32-bit space. Thumb instruction set consumes 16-bit space. The method of writing a code in traditional ARM processor is writing a code using few instructions of the ARM instruction set and few instructions of Thumb instruction set. Whichever instruction, whichever job or operation is possible using Thumb, use Thumb instruction sets to implement that part of a program. And if it is not possible to implement certain part of a program using Thumb instruction set, then use ARM instruction set to implement that. In that way, by using few Thumb instructions and as well as few ARM instructions, program is written for any applications. So that program will use less memory because of Thumb instructions, and it will do most of the powerful jobs also by using ARM instruction set, because Thumb instructions, if some complicated jobs is not possible using Thumb instruction set. Not only that, some decision making jobs also requires ARM instruction set to implement. That's the reason by mixing Thumb instruction set and ARM instruction set, traditional microprocessor program, ARM processor programming is done. But where there is a one requirement, that is to execute a program in Thumb instruction, to execute Thumb instruction set, processor should be in Thumb mode, and to execute ARM instructions, processor should be in ARM state. So there is a one bit in the flag register. That bit should be set or reset to change the state from thumb to arm and arm to thumb. So this is a way of traditional ARM processor programming. Main important thing is traditional ARM processor programs may consist few thumb instructions and few ARM instructions. Thumb instructions are all 16-bit width and ARM instructions are 32-bit. So to execute a thumb instructions, processor should be in thumb state. To execute ARM instructions, processor should be in ARM state. But thumb instruction set, traditional thumb instruction set, do not consist in instructions to handle complicated operations and as well as decision taking operations. Okay. Later, the thumb instruction is developed to thumb 2 technology. So this is thumb 2 technology is extended the thumb instruction set architecture. In the sense, few more instructions are added to the thumb instruction set that is called as thumb 2 into highly efficient and powerful instruction set. Why powerful means? So thumb 2 instruction consists some decision making instruction as well as some powerful math related instructions to handle complicated operations. The reasons what we say the thumb 2 technology extended the thumb instruction set architecture into a highly efficient and powerful instruction set that delivers significant benefits in terms of ease of use, code size, and performance. Okay. The extended instruction set in the thumb 2 is a superset of previous 16-bit thumb instruction set. As I told earlier, the thumb 2 instruction set consists the previous 16-bit thumb instruction set with additional 16-bit instructions. Few more additional 16-bit thumb instructions are added to that set alongside 32-bit instructions. These are also 32-bit thumb instructions. So thumb 2 technology consists once again previous 16-bit thumb instruction set with additional 16-bit instructions alongside 32-bit instruction. It allows more complex operations to be carried out in the thumb state, thus allowing higher efficiency by reducing the number of states switching between arm state and thumb state. Because this thumb 2 technology consists 32-bit thumb instructions also and some of few decision making instructions also. That's the reasons more complex operations can be carried out in the thumb state itself because we are right now complex operations we are implementing using thumb 2 technology instructions only. That's the reasons ARM processor can handle complex operations in thumb state itself, thus allowing higher efficiency. Why higher efficiency means by reducing the number of states switching between arm state and thumb state. In olden traditional processors or in traditional ARM processors, there is a requirement or there is a requirement to change this state from ARM state to thumb state. Means changing the state means changing these bits of this flag register, T bit of the flag register, to 0 to 1 or 1 to 0, before we switch from ARM to thumb and thumb to ARM. This takes some amount of time. So this is now avoided. So there is no point of changing the state from ARM to thumb and thumb to ARM. So all the instructions are thumb instructions only, and we handle all the jobs in the thumb state only. So now thumb 2 technology instructions are powerful, and even decision making instructions also it consists. So all complex operations we can handle in thumb state itself. So in this picture here shown, this is thumb 2 technology instructions. So what are it consist? Consists 32-bit thumb instructions and as well as 16-bit thumb instruction set. These 32-bit thumb instructions are added extra. It was not there earlier, but in the thumb 2 technology this is added. And this 16-bit thumb instruction set, here it consists few more newly added 16-bit thumb instruction, and along with the traditional thumb instruction set. So thumb 2 technology consists 16-bit thumb instruction set and as well as 32-bit thumb instructions. So what about our Cortex M3 processors? Its instruction set consists few instructions of the thumb 2 technology. Not all, few instructions of the thumb 2 technology. So that's the reason it consists 32-bit thumb instructions, also some decision making thumb instructions, and as well as classical thumb instructions or traditional thumb instructions. The focused on small memory system devices, because why we go for thumb instructions means normally most of the instructions in the thumb instruction set as well as in thumb 2 instruction set, most of the instructions are 16-bit. Because of that, the total size total size focused on small memory system devices such as microcontrollers, and reducing the size of the processor. The Cortex M3 supports only thumb 2 instruction set. So Cortex M3 processor not supports ARM instructions. Only thumb 2 instruction set. Because we need to reduce the size of the codes, because it is suited for microcontrollers usually which consist of less memories. Instead of using ARM instructions for some operations as in traditional ARM processors, it uses thumb 2 instruction set for all operations. This is very important point. Instead of using ARM instructions for some operations as in traditional ARM processors, it uses thumb 2 instruction set for all operations. The Cortex M3 processor is not backward compatible with traditional. Nevertheless, the Cortex M3 processor can execute almost all 16-bit instructions. 16-bit thumb instructions, including all 16-bit instructions supported on ARM7 family processors, making application porting easy. Cortex M3 processor can execute almost all 16-bit thumb instructions, including all 16-bit thumb instructions supported on ARM7 family processors, because previous ARM7 processor supports 16-bit thumb instructions, that is also supported by Cortex M3 processors. Support for both 16-bit and 32-bit instructions in the thumb to instruction set. There is no need to switch the processor between thumb state and ARM state. This is very important. With support for both 16-bit and 32-bit instructions in the thumb to instruction set. Right now, thumb to instruction set consists 16-bit and as well as 32-bit instructions. So there is no need to switch the processor between thumb state to ARM state, because all the powerful jobs, complicated jobs we can handle using these 32-bit instructions. So there is no requirement to switch to ARM state. We are handling everything right now in thumb state only. For example, in ARM7 and ARM9 family processors, you might need to switch to ARM state if you want to carry out complex calculations or large number of conditional operations and good performance is needed. Because in ARM7 and ARM9 cases, there was no suitable thumb instructions to handle the complex calculations and conditional operations in a good manner. So there was a requirement to switch to an ARM state, and using ARM instruction set, there is a necessity to implement a complex calculations part of a program and some decision making part of a program to get a good performance. Whereas in the Cortex M3 processors, you can mix 32-bit instructions with 16-bit instructions without switching state, because everything is belongs to thumb 2 technology, so everything we can execute in thumb state itself, so there is no requirement to switch. Getting high code density. Why? Because thumb instruction, usually most of the thumb instructions are 16-bit, so the program which is built using thumb instruction set usually takes less memory. That's the reason high code density. Code density means using less memory we can achieve more jobs, we can perform more jobs. And high performance. Why high performance? Means everything. High performance means high performance jobs, high performance instruction set consist to implement a high performance jobs. Because right now we have a 32-bit instructions also with no extra complexity, because there is no requirement to switch the states. The thumb 2 technology instruction set is very important feature of ARM v7 architecture. Compared with instructions supported on ARM7 family processors, the Cortex M3 processor instruction set has a large number of new features. So Cortex M3 processor's instruction set has a large number of new features. For the first time, hardware divided instruction is available on ARM processor. In a Cortex M3 processor, hardware divided instruction is available, and a number of multiply instructions are also available. So its instruction set consists a number of several multiply instructions. to improve data crunching performance. So this is one advantages. The Cortex M3 processor also supports an aligned data access, a feature previously available only in high-end processors.